Alrighty, share screen, present. Can you guys see it? Awesome. Alrighty, I think we're ready to go. All right, so I'll start over. So hi, I'm Scott. I'm a fourth year Mechie. This is my fourth year in the club. I've been doing mechatronics work for each of the past two, and then this will be my third. I will let you introduce yourself, Andy, real quick.
Yeah, I'm a second year Mechie. I've been doing sort of assorted rocket stuff, sort of crossover between airframe and mech for the past year or so. It's been fun. Learning a lot from Scott and others. This club's great for learning.
Andy wears many hats. So alrighty, so this is the mechatronics track, as you guys probably know. I am one of the leads, and then Bryce, who may or may not show up at some point, is the other lead. So the objectives of the mechatronics track at the end of the day is to design rocket payloads. So there's kind of two main areas of mechatronics that the club focuses on. One is payload systems. Payloads, for those of you who don't know, are basically any system that you put inside of a rocket that doesn't really aid the function of a rocket at all. It's basically using the rocket as a transportation vehicle, and the rocket brings it to a different place. In amateur rocketry, that place is usually just high up in the sky. For professional rockets, NASA rockets, whatnot, that could be the moon, space station, or Mars, all those places. So for us, most payloads are rovers or landers, and the payloads that you guys will be building are landers. The other mechatronic systems that the club builds are like rocket components. So there's like different parachute deploy systems, different electronic space, and there's a bunch of fun little mechanisms which have kind of become Andy's bread and butter. So if you have any questions about that sort of stuff, he's probably your guy. So in terms of the skills that you guys are going to learn, 3D modeling is obviously really important for mechatronics work. So we're going to be focusing on teaching you guys SolidWorks. There's not an expectation of coming in with CAD knowledge. If you do, that's great, and we'll build off of that. But if you don't worry. The next thing is prototyping, and specifically additive manufacturing and other types of manufacturing as well. But especially in a COVID world, it's going to be easiest to focus on manufacturing through 3D printing, because it's easier to do that when you're not there. The next thing is testing and iteration with any kind of systems that you're putting in rockets, especially things with small electromechanical components. Failures happen a lot, and so getting through rigorous testing and iteration to come up with designs that are relatively bulletproof is really important. Integrating electronics. You don't have mechatronic systems if you don't have electronics. Robots, rovers, landers, and all these things kind of rely on the interface between the electronic systems, sensors, and whatnot, and the mechanisms that we design. And so figuring out how to integrate those is super important. And then preparing and presenting design reviews. And this is something that even if you've had past experience in mechatronics fields and robotics and whatnot, you may or may not have had experience with design reviews. We feel it's really important to, give people the skills to present their work and have people pick it apart, give them suggestions for future improvement, as well as just in general share the work that they've done. It's a really important skill for job interviews, and it's also really important for in jobs. Design reviews are widely used at engineering firms, so it's been really good for me personally, and I know a lot of other people, to get exposure to that sort of thing. So on this slide here, you see several pictures. The bottom row is the payloads that we've built the past couple of years. The bottom left being last year's rover, bottom middle being a picture of the rover once we built it, and then bottom right being the rover from 2 years ago. And if we have time at the end, I can come back and talk about those. The top left is a picture of a parafoil ejection and control system, which is a little more complicated, and again, I can circle back. And then the top right is one of those dual deploy rocket mechanisms for parachute ejection, controlled ejection. So the format of the track, so we meet once a week on Wednesday nights from 8 to 10 p.m. starting this upcoming Wednesday on Zoom. So the structure of the classes is that we'll be focused on, or we'll do 15 to 20 minutes in the beginning generally, where one of the mentors, could be me or could be Andy or any of the other ones, will present on a specific topic that will help you with the design of your system. And the theory is that by the end of the semester that you'll have gotten exposure to kind of a lot of the main principles needed to design the sort of stuff that we work on. And after that 15 to 20 minutes, we'll go into breakout rooms where it will be 7 people. We're focusing on groups of 3. So it will be you and your 2 teammates. Every group will have a sibling group that will work somewhat closely with. And then the main purpose of those sibling groups is that you share a mentor. So we have a whole set of mentors, myself and Andy are 2 mentors. And then I've mentioned Bryce, there's also Peyton and Emma and Nathan. So you will, if you choose the mechatronics track, you will meet all of them. And so the 6 of you guys will share one of them and work on designing your landers. Software that we use, I mentioned SolidWorks already. We use SolidWorks in conjunction with GrabCAD, which is a CAD sharing service. If you've done code and stuff before, it's like the GitHub of CAD. And then other information will be stored in the AeroNew Google Drive, which will get you guys on. So in terms of an outline of what the course covers, the first week is Intro to Mechatronics. I realized that if you went to Fall Fest kickoff this and next week, that's a lot of introductions. I promise once we get into the meat of the course that we're gonna stop doing a bunch of introductions. We just want to make sure that people have, that we don't leave people behind that maybe weren't able to make some of those things. So I hope that each one of these has slightly more information for you guys. And again, once we hit SolidWorks 1, I promise, no more intros. SolidWorks 1, 2, and 3 are relatively self-explanatory, getting you guys up to speed on 3D modeling. Then we'll actually give you guys the challenge for the lander, the full details for scoring and whatnot and constraints. And we'll walk you guys through how you do whiteboarding and just kind of start breaking down any kind of engineering challenge. Next, we focused on motors and gearing, then different manufacturing methods, selection of COTS components. COTS is commercial off the shelf. So, you know, if you go on Amazon, DigiKey, McMaster, or to name a few vendor websites, you know, how do you select parts? How do you know what you need? Then after that, we'll do one lesson on some SolidWorks FEA sims. We'll move into, as I was talking about earlier, design reviews. You know, what are in-design reviews, especially the one that you guys will be doing, which is that last meeting, PDR. PDR stands for preliminary design review. The 9th is the last day of classes. So this takes us all the way to the end of the semester, where you will present to me, your mentor, and then 1 to 2 other AeroNew veterans about the work that you've done over the course of the semester. And we'll kind of give you pointers. We'll talk about what your next steps are, and you can talk about the stuff you've learned. So this is the timeline in just kind of a slightly different format. I'm just going to kind of go over this quickly because it's most of the same stuff. But once we get into the beginning of October is going to be that SolidWorks period. And then pretty much from mid-October all the way through the end, we'll be on the design of those lander systems. And if this showed into January and beyond, which it doesn't because not all plans are locked in place yet, but the tentative plan as of now is that you guys will continue working on those and building those through the end of the spring semester as well, in which case, or at which time you'll be able to put them into the intro airframe rockets and launch them. This is somewhat dependent on Northeastern allowing us to meet in person some in the spring and be able to build, but we're crossing our fingers and hoping that that's possible. And if we get through a lot of design stuff now, the hope is that we will be set up well in January to move on to that. So that is the end of the content I have for you guys. I'm going to open it up to questions. If you guys have not already, please, which I don't think you would have because it's the first track run through. So scan the QR code here to let us know that you were here. We want to know who was at all the different meetings and express your interest. This is not for Mechatronics specifically. This is just for intro in general, just so you know. So yeah, so I'll open it up for questions now. If anyone has any.
So you need to be logged into, yes, this is a fun one. I don't know how it works for the US, but I think if you go to Google Drive and log into your Northeastern username at Extension I have here.
Nothing, guys.
I have a question.
Go
How
for
do
it.
we sign up?
Yeah. So this right here, this QR code expresses your interest, which is important. But then tomorrow, which is Friday, right? Yeah, tomorrow at 11:30 a.m. there's going to be an email sent out to everybody that's on the club email list that will have a link to a Google form, and you can sign up for what your preferences are for what tracks you want to take, first through fourth. And yeah, and I will offer a word of caution. I cannot speak to what will happen this year, but in the past, intro has filled up in as little as under a minute. So make sure you are on your phone when that email comes in, because it fills quick. Sometimes, usually. It always has before this year. I'm done guessing what's going to happen in a COVID world. I never know.
When I scanned the QR code, it said that I need permission from.
Yeah. So yeah, this has been happening. So most of you guys don't have the Google account signed in on your phone, which is understandable because we switched to Outlook now. But your your at husky.neu.edu account is the one that can actually sign up with the form. Another option is we can just post it in the chat, and I'll ask Shayla to do that. She did that last night too. It will be the exact same thing. So
Okay.
yeah, when you guys go back to the main room, I'll have her do that again.
All right. Thanks.
No problem.
Yeah, weekly today.
Is there any way to do it so that like
Talking to John
you don't have to be?
So yes, but we wanted to collect emails that way.
We wanted Northeastern emails.
Yes.
Yeah. Mm-hmm.
And if you enforce it being the Husky emails, then we know that it's just at Northeastern instead of .husky.neu.edu. Like, we know all the prefixes are right.
Yeah.
It's still annoying,
That is true.
admittedly.
Any real questions though?
I suppose. How does Mechatronics fit in with, say, a larger rocket projects like Redshift, or just in general? How does this go to there?
That's a great question. I can take this, but Andy, since you're literally working on this in DPF, you might be the most qualified to answer it.
Well, yeah, right now for Redshift, this isn't necessarily the way it always works with rocket projects, but right now with Redshift, the Mechatronics stuff is mostly, we've got a triple deploy mechanism we're building. So that's a mechanism to control 3 parachute deployment events, because the Redshift rocket's going to at least 20,000 feet. So to control that long descent and prevent the rocket from drifting all over California, and also to prevent it from destroying itself when it hits the ground, we're going to have 3 parachute deployment events so that we can, find or, precisely control the velocity. So that's useful. And that's definitely Mechatronics. Then the other thing that we're working on right now that sort of falls into that category is a nose cone assembly that involves airspeed sensors and a load cell to measure the axial force on the nose cone, so that we can get coefficient of drag data on the nose cone, so that the Sims people can better model the behavior of the rocket. Then also that includes, to some extent, electronics bay design. So that's not really mechatronics per se, but it is the inside of the rocket and that goes on there. And there's a lot that needs to go into this, into the Redshift rocket, because it needs to be able to control the liquid rocket engine. So lots of big batteries, all the circuitry to control that. That's kind of avionics, but we have to facilitate that in terms of internal structures. Also an umbilical cord. We're designing an umbilical cord, or John and Alessio is, to allow the rocket to communicate with the ground station and to receive power and potentially coolant fluid or something while it's on the ground. So yeah, stuff like that, and controlling pressure and controlling prop valves and stuff like that to a certain degree. But yeah, the big thing is the parachutes. That's probably the biggest thing.
Yeah, and to add on to that, you might be wondering how like rovers and landers translate to that, because those are not the same thing, and I'll admit they're not the same thing. But a big thing with designing internal mechatronics structures for rockets is like just becoming familiar with the design space and using the skills. I can tell you that the skills required to design these rovers and lander systems translates really well to these other rocket internal mechatronic systems. And so the idea is to give you guys a place where you can work on developing those skills discreetly from whether or not the rocket is going to work, especially because we have the airframe group that is already designing those rockets that don't require these systems. Those rockets are small enough that we can build them through more conventional means. And so it gives you guys a place to kind of have fun with it too, because when we're making landers, that means that we get to decide the rules of the landers. And so they can have objectives that are just fun, just for this, because we wanted to. And then, so it's just like an internal competition and whatnot to kind of build skills in that design space. And then after that, you'll be experienced designing small parts for small tubes.
That's the big thing, right? A lot of this stuff looks like, oh, well, that's not that complicated of a mechanism, but it's when it has to handle, I don't know, 700 pounds and has to fit in a teeny little tube, it becomes a lot more difficult.
Designing parts for tubes is like the story of a mechanical designer in Aero and U's life.
Yeah, it's non-trivial. And if you look at, the rover they built last year too, there's a lot more going on there too.
Yeah, if Bryce was on, he could show you. He has it in his apartment, but you can kind of see in that semi-transparent render. Yeah, there was 6 motors, 6 motor controllers, 2 servos, a set of battery cells, several control boards, some other stuff. It was
parachute detachment thingy.
Yeah. Oh my God, that thing was such a nightmare to package. Yeah, so just to be clear, the reason we designed that last year, so we were in the NASA USLI, which is University Student Launch Initiative competition last year. So there was a rocket component of that, or launch vehicle, and then a rover component of that. So there was a team. So this wasn't just intro, that was also veterans. Like I was a 3rd year working on that. And so, yeah, that had to, rocket went up. Then when the rocket's under descent, undershoot, the rover is ejected from the rocket, lands on the ground, moves through some means. In our case, it was like a walking motion with those legs, to one of 5 locations in the giant field where we launched that are marked with a tarp. And then it had to collect a sample of material that was at the said tarp. That's what those scoops were for. And then I had to move an additional, I think, 6 or 10 feet or something like that. So yeah, that was the challenge. And so actually I mentioned that parafoil control thing in the top left. That was the concept with that, was that it would be attached to the end of the rover. And so when it came out of the rocket, we would use parafoil to guide. Parafoil, for those of you who don't know, is a guided parachute. It's like the rainbow shaped parachutes that you might see like people ride, and like you pull on one side and you go that way, that kind of thing. So the idea was to have the rover be riding on one of those that was autonomously controlled towards one of the goals, and then land, and it wouldn't have to go along the ground for as far, which the main purpose of all of that was to save the rover from needing a just massive battery in it, so they had to be able to go across an entire giant cornfield, because that's hard. Weight, that's the other thing, it's space and weight. when you're designing stuff for rockets. Stuff needs to be relatively light usually. So
That's getting into the advanced stuff. We can teach you stuff you do.
I guess the other thing I forgot about is
Embedded stuff.
mechanical separation. That's another thing we're working on. Instead of using black powder to blow parts of the rocket apart, to have a mechanism that can handle that. But that's just a side note. So how much time do we have?
I don't know.
Does Shayla call us back or something?
Yeah, she calls us back.
Okay, that's cool. Any other questions?
I'm all set.
Okay,
Super cool.
it's good.
Cool. And the other three of you guys, what brings you here today?
I'm undecided, so I kind of thought that Mechatronics give me like a pretty wide deal. Like I could kind of experience a lot of engineering at once.
Yeah, that's fair.
That's
Better.
probably very true, I think.
Yeah, I would agree with that assessment.
Definitely
So,
more
yeah.
so than airframe, I
So
think.
we can all, except for Jose, I'm gonna have you stick around for the next group.
Yeah, I will say the mechatronic stuff in general is like there's definitely a heavy dose of mechanical engineering, but there's definitely also some of the other disciplines as well. Like someone has to do the software on these. It's probably you guys.
I mean, I'm willing to do software if I know how to do it.
Yeah, don't worry. With all this stuff, it's not like we're just gonna be like, go do it, figure it out. Yeah, no, that's not the point. This is a track intended to teach you guys. It's not gonna be like spoon fed. Like you guys are gonna have to figure stuff out, but we are going to teach you the skills in order to do so. And you'll have a mentor working with you. So like if you get stuck, you're not gonna just be banging your head against a wall. Like we'll make sure you guys are moving forward. Learn lesson. Yep, go for it.
So right now I feel like I'm gonna be pretty dang busy with my classes. So how much work do you think we spend on stuff for this club each week?
Yeah, so for intro itself, the expectation for each of the tracks is really only that you come to your meeting. We do ask, okay, I'll finish asking this first and then you guys can go back. We do ask that people come, ready to learn and work for the actual track meeting itself, but that's only 2 hours a week. There will be people that probably want to work in addition to that outside of meeting times. That's people's right, and I'm not going to get in the way of that, but it is not an expectation that people work more than 2 hours a meeting. Or sorry, 2 hour, yeah, more than the 2 hour meeting, which is once a week. So you can work as little as 2 hours a week, basically, is the answer.
Okay, thank you.
If you guys don't have any other questions, you guys can head back to the main room. But if you do, you can hold on for a sec and ask me. Yeah.
All right, should I stop recording here?
Yeah.